team space. This is team space lasers. So we were working with LiDAR, looking at snow depth. So our group goals were to use GitHub to collaborate on a project, using branches and command line, just becoming more familiar with it. We were initiating and expanding our Python abilities. We're working within notebooks and working on workflows for accessing data for easy reproducibility. Compare the snow depth based on ISAT2 ATL08 data with the SnowTel and the SnowEx ground data as a way to validate it. And we wanted to evaluate whether or how vegetation impacts ISAT2 derived snow depth accuracy. So I have a little video, but we'll go ahead and pass it just because they tend to be running a little long. If anybody would really want to see that at the end of this presentation or is curious, I'll be happy to show it if we have time. Ooh, maybe not. Okay, there we go. As for ISAT2, it is a spaceborne LiDAR. So it has a 91-day repeat track orbit. It does 6 beams in 3 pair segments. It goes getting our photon height, and it's got multiple products, including sea ice freeboard, sea ice land height, and what we were particularly interested in is the ATL08, which is the land and vegetation height. So it's going to get our ground and canopy surface height for us. And I think that's it for me. Unless I missed anything, we'll switch it over to another person.
Hey all, my name is Hannah. And so when working with ISAT2, we know that it's incredibly important to have a high quality snow off data set. ISAT2 tracks, for the most part, don't overlap each other. ISAT2 was created with the goal of measuring ice cap and ice sheets at the poles. And then the secondary goal is to study canopy structure at lower latitudes. And then in order to capture like a higher spatial coverage of the globe, they purposefully point the satellite off nadir so they don't have repeat tracks trying to capture that greater spatial coverage. But because of this, it's really rare to have 2 ISAT2 tracks that actually overlap spatially, just like you would need to measure snow depth. So there's no, or very, very few ISAT2 tracks where you have a snow off data set with a snow on data set for that same location. So because of this, we need a really good reference elevation data set for our snow off that we can then use to find snow depth from snow on ISAT2 tracks. So the 3 depth data set is really high quality digital terrain model. And we were able to use it for the Grand Mesa site. You can see the extent of that data set on the left-hand side. And we kind of just barely got an ISAT2 track to fit it. I'll show you that later. But then I was able to clip that data set just to the very flat areas of the mesa. So we were only looking at the ISAT2 track as it went over the flat, smooth area on top of the mesa. We've run into some issues with ISAT2 data on steeper slopes and in rough terrain. And so Grand Mesa provided a really great opportunity to study the ISAT2 data in a location that's more similar to what it was meant to study, which would be flat, smooth ice sheets. So working with the Grand Mesa data was a really great opportunity. Next slide. So like I mentioned, unfortunately, there weren't that many midwinter tracks for ISAT2 that overlapped the Grand Mesa study area. But we were able to identify one that was taken within a reasonable time of the ground campaign. So the ISAT2 data we were working with was from March 11th. And thanks to some of the great tutorials this week, especially Ben Smith's tutorial and David Sheen's tutorials, we were able to access our data fairly easily through open altimetry using a workflow developed primarily by Ben Smith. And then we're able to convert the data into a geodata frame, as one of the previous groups was talking about, for the ability to work with it easily. And then we interpolated from the ISAT2 points, pulling out points from the reference DEM. So that's what you can see in this right-hand part of this figure. The blue data is the ISAT2 tracks, and the orange data is the digital terrain model tracks. And you can see that our supposed snow on data is below the snow off data, which should raise alarm bells. And anyone in the LiDAR tutorials will remember that there can be issues between datum offsets. So next slide, we were able to correct for those offsets. And now you can see that our snow on data is above the bare earth. And the differences are much smaller. So we see maybe some reasonable snow depths in there. All right, next. And then this is just showing like a scatter plot of the snow depths we derived from the ISAT2 data. We have the ground at 0, and the mean snow depth across the track was about 0.35 meters of snow depth, with a standard deviation of about 0.2 meters. Next.
Okay, I'm Chelsea, and just like Hannah was saying, so we derived snow depth from ISAT2, but now we need to see how well is it doing. So we pulled up some other instrument data that's measuring snow depth to compare. So first off, just looking at this plot, down here below, we have, in the gray, we have SNOWTEL, and in the purple, we have SNOWTEL as well. And you can see that red X, that's our ISAT2 snow depth. So it's lining up pretty well with the Mesa Lake SNOWTEL site. Up above, we have our ground measurements, as well as our camera snow depth measurements as well, which is following the SNOWTEL pattern pretty well, but as you can see, there's quite the offset. And I don't know if you can see, there's like a red triangle, that's our ASO snow depth as well. So all these different instruments coming together, measuring snow depth across Grand Mesa. Oh, yeah. And so when we first started off, we wanted to create a spatial mask so that we're looking in roughly the same area as the ISAT2 tracks. If you want to go to the next slide. And so it looks something like this. These are all the points that we were taking into consideration. But after putting our PowerPoint together today, we noticed, or looking at Hannah's slides, we realized that we didn't refine our spatial mask well enough, just seeing the ISAT2 tracks. So we narrowed it down to make it more accurate. So if you go to the next slide, these are actually the points that line up better with our ISAT2 snow track, our ISAT2 tracks, sorry. So as you can see, we went from quite a few points to about five or six. But that's the beauty of Hackweek, is that we were able to rerun all of our code very quickly because of all the great tutorials. So thank you for that. And so based on just these few points, if you want to go to the next slide, here's our updated plot. And so it kind of got rid of the GPR, all of those measurements. We just now have the camera and the pit ruler. And you can still see that ASO is lining up pretty well with the camera data, and our snow depth from ISAT2 is still lining up really well with our SNOWTEL Mesa Lakes. And now Elin will tell us a little bit more about this spatial variability.
Yeah, hi, I'm Elin. Like we mentioned in the beginning of this presentation, one of our goals was actually to see how the vegetation conditions affected the return or the retrieval of the snow depth from ISAT2. We didn't quite get as far as we liked with that project. So this is more of a kind of overview on NDVI seen from Sentinel-2 that we produced. Also just comparing all the different locations of the data that was used and as anyone who's worked with snow, we all know that it's a very variable measurement. So as to how much we can actually say that these snow depths are very representative from the ISAT-2 track is a bit difficult. Therefore, in the future, we would recommend that at a campaign, maybe we could, for example, track up the snow depth where we know that an ISAT-2 will have a flyover path or other instruments, for example, so that you get a better comparison of those points. You can see that there is a bit of overlap over the blue ISAT-2 line, and the ASO flights and the snow pits are all in this red shades. We would also like to do some further, if we have time and we still work together. We know that there are some other ISAT tracks in the area that pass through a bit more of the westerly part of the Grand Mesa, which is mostly gray on this map, where there should be some deeper snow as well, which might make it easier to compare the vegetation effect. Next slide, please. Yeah, so like I mentioned, the spatial variability across the mesa impacts the snow depth for sure. We're quite happy that we got a reasonable snow depth value from the ISAT-2 and the 3 depth difference. Yeah, and we think that this would be a really cool thing to do, especially in other areas, in other flat areas with high quality DTMs. And a bit more field analysis geared towards satellite tracks. I think that's it. I think we, next slide, we'd like to thank everyone. We've learned a whole lot, and it's been really great to be able to meet so many other people. I think speaking on behalf of people who wouldn't have been able to travel to the US, there's a silver lining in doing this on Zoom. So thank you.